So hey, hi all. In this segment, I will be explaining how we can leverage AI. So we have AI workload, which has associated logs with it, right? We can export these logs to Sentinel, which is a SIM solution, and then we can write detection rules, and these detection rules will be in alliance with WASP top 10 for LLMs. Right. Also, we can check the mapping mapping with the we can check the mapping with MITRE, ATT, which is adversarial tactics, techniques, and common knowledge, right? Why we need this? Because when we create a detection rule, we need to map this, and this will be the base so that we keep our focus on the real threats, focus on. So I'll be explaining the OWASP top 10 for LLM and OWASP top 10 for agents with an analogy and what MITRE framework or MITRE can be mapped to the creation of the detection rule, and we'll give you a brief on the detection rule as well. So let's get to here. So if you see here, what we have is the first one, which is LLM prompt injection, right? LLM prompt injection. Hmm. So consider it like someone slipped fake instruction in your robot. So your robot or some LLM or model with which you are interacting, right? If you put some fake instruction into it, just from the aspect or perspective of getting something out of it, right? Or to check if to what extent the adversarial mindset will work. So that comes under prompt injection. So prompt injection is a way to dissect the model from its regular functioning. Now if you want to do the detection, mostly when we write something to the model, like I want to understand how to make a bomb or how to loot a bank, so it usually responds like the models like ChatGPT and other one. They are pretty much strengthened towards the prompt injection attacks, but this is LLM 01, right? And they usually respond with ignore previous instruction, system prompt, developer mode. These are the more instructions which are usually been given as a part of the prompt. So if you are able to detect maybe whatever ingestions you are making for the logs you are ingesting, and if it gives us that details of what prompt was given, so then we can detect those, we can write an anti-rule based on that. Then second LLM is OWASP top 10. The second one is LLM 02 is sensitive information disclosure, where we tend to see some sensitive data getting leaked, like SSN or PII data, right? Person identified data. So this would fall under the collection and exfiltration. For prompt injection, for MITRE Atlas has the direct map for prompt injection, and for LLM sensitive information disclosure, that is mostly collection and exfiltration. So that is the data which you would like to exfiltrate, so that you can, when you're creating your detection rule in Sentinel or any SIM solution, you can map that as a collection or exfiltration there. And then detect response containing API key, password, SSN, credit card rejects. So if you detect something from the message field or any field for the log you ingested or DLP policy match, you can create a detection rule. Then we have supply chain, which is considered a model which is built with bad Lego pieces or bad input, or the tools which are used to create are bad maybe. So data poisoning could be the address, matter. Atlas. So large unexpected vector index updates, abnormal document ingestion volume. So that is data and model. Okay, that is data and model poisoning. But we are looking for supply chain components. Detect new model deployment, unsigned plugin installation, container image has changed, unexpected package versioning. So these are all the example of supply chain compromise. Then data and model poisoning, where we are intention is to poison the model. Someone edit the so to a simple analogy is like if you edit the robot's textbook. So data poisoning. So large unexpected vector index updates, right? Then improper output handling. So output which is given. So but delete everything. Execution. This is focusing on the execution and the impact part of my Let's now detect AI response containing shell commands, PowerShell, SQL statements, JavaScript, HTML executed by downstream applications. Right? If you tend to get these detected, then you can mark that way. Then excessive agency, right? If you give more access, make it over privilege. A privilege escalation is one of the tactic. Yes. So detect AI calling admin APIs, deleting resources, multiple graph actions, key for vault access outside baselines, etc. So these would be the one. Then vector and embedding weakness. So robot picks the wrong libraries, retrieval manipulation. So by detect retrieval from unusual collection, sudden drop in retrieval score, excessive embedding updates, unauthorized vector DB rates. LLM misinformation, robot confidently lies. So hard to directly flag, low confidence answers repeated, user correction, DPOL, faithfulness failure. So faithfulness is how much you can trust on that, right? The trust factor comes with what it is responding. Are we getting the right information or we are getting misinformation from the model which we are in? So that faithfulness from DPOL can help us here. Then misinformation or resource exhaustion. Robot gets tired answering huge questions. So DOS, denial of services. So these are the OWASP top 10 for LLMs, right? And key MITRE tactics which we have used is prompt injection, collection, exfiltration, which is sensitive information because of supply chain for supply chain one, and data poisoning when the model got compromised in terms of the training. Delete everything which is execution, the impact on proper output handling. Detect AI response during shell commands, right? So this is how you can detect this. Then OWASP top 10 for AI agents, right? AI agents. So agentic risk is goal manipulation. So someone changes the robot mission. So agents are, as you know, we have models, and on top of models we build the agents. Now agents are something which are very goal oriented, right? If your agent goal is to migrate or is to generate data collection rules for the log source which are migrated from via Cribble to Sentinel, so then it should be working that part. It should not deviate from it. Correct. It should not be giving you itinerary to travel to Europe, right? Someone changes the robot mission or the goal of the agent prompt injection. This is an example of a prompt injection. So sudden goal change, prompts overriding objectives, conflicting tasks change, right? Then we have memory poisoning, fake notes added to robots diary, data poisoning, unexpected memory writes, abnormal vector updates, unauthorized memory modifications, right? No, fake notes added to robots data poisoning, unexpected memory writes, abnormal vector updates, tool misuse. So robot uses your parents' credit card. Tactic meta tactic is execution and it detects unusual. So how you will do the detection in Sentinel or any SIM solution? You need to ingest the logs and try to check if you get to see the detection of unusual tool invocation, PowerShell, GitHub graph, API or service or SAP calls being made. Excessive permissions, robot has every house key, which is privilege escalation. So agent authenticating as a global admin owner role. But authentication permissions related logs. We are a multi-agent trust abuse. So if they ask you to give you any examples, or you can give examples like I can ingest the logs and based on what logs I have, I can analyze what we have in it. So we can check, for example, if I do check for prompt injection, I can check response field or maybe the input field. What is the content of input? Is it like forget everything and then start afresh, or there are strings like uh, you like bypass the system prompt like that. So these are the comments I'll be looking for, right? Then identity spoofing. Bad robots pretends to be your teacher. Impersonations, token replay, unusual manager identity usage, impossible travel, MFA anomalies. Hmm. Then planning, identify identity spoofing. Bad robot pretends to be your teacher. Impersonations, token replay, unusual manager identity usage, impossible travel, MFA anomalies. Then we have planning. Manipulation. Someone change the treasure map, execution manipulation. Okay, secret leakage, unsafe autonomy, monitoring flavors, failures. So app traces, this is for so where message could be a field, and then you can see system prompt, developer mode, jailbreak, DAN, bypass safety, and any message which comprise of that for a given duration. If count is more than threshold, so it will generate a light. Then sensitive data leakage. Sensitive data leakage is one of the when giga resource exhaustion. So summarize total tokens, some token use so user who 5 minutes total count is this request. Okay, so this is fine. But the other thing which I would like to show you is this. So see, these are the top three detection from OWASP top 10 for prompt injection. Where so signals content safety. I will be explaining content safety in upcoming session, but the key here is to understand this one. So true request response logs, keyword in prompting, not previous instruction system prompt, and if you get to see this, then you should be generating sensitive information disclosure. Response payload usually contained the API key, JWT connections, and credit cards. Spike in outbound token volume per. So this is basically looking for response matches rejects this. Model denial of service, analogous search, total token, prompt token, private. Throttling spikes. So, okay. So this is about what I have discussed around the fact that AI workload when we export the logs and then export these logs to Sentinel. I think I have here as well, right? So this is how the logs look like. Azure OpenAI KQL workbook use case. So this is not work. Yeah, this is workbook use case, but this is how Azure Diagnostic have request response category, subscription resource. This is our Azure OpenAI Microsoft AI Dev 01. So logs. So then we can have schema of Azure Diagnostic. This is the schema. Okay, this is how these are the content. Now detect unauthorized model use in OpenAI. So unauthorized users compromise API keys or misconfigured applications can attempt to access restricted AI models in Azure OpenAI. Attackers may try to exploit misconfigured access control, abuse API key, and brute force API endpoints. So we can check for all the non 200 response one. 200 is successful, but non 201 could be under these API key abuse unauthorized. So Azure Diagnostics extend parse properties. I'm parsing the properties one, parse JSON properties. and then I'm extending the model deployment name to string, which is how I extracted the model name, and where I'm looking for result signature not 200, and summarize failed attempt counts. So this was the output for this IP address with this operation name chat completion create. For this model, the result signature is to 429. So 429, 429. So I've got some output here for this, right? Similarly, for unusual model usage, OWASP insecure model hosting. So if you see OWASP rating, OWASP, we didn't have mapping for OWASP. Attackers may attempt to access restricted LLM models for malicious purposes, right? Detection goals: identify unauthorized or unexpected model usage detection method. Track which models are being used. Example text embedding 3. Identify anomalies in model deployment. So which models are being used and what is the anomaly. So parse property to accept the property, right? Model deployment name and usage count by model. So which model is used for how much time for the last 1 hour duration. Okay, for some reason the image is not loading here. Mm. Okay, let me just give it a refresh to see if it is giving. Okay, my net got disconnected. Just a second. Hmm. So the use case is 429 and not 200. So we have got one result here. And then attackers may attempt to access restricted LLM for malicious purpose. Yeah. So the purpose usage count. So for 1 hour, I've just captured the model deployment name and the time. It's a 1 hour window. What is the usage count? If there's a high spike, we can give that count spike threshold, and then we can specifically focus on it, right? Like that. Then security focus, Azure Workbook for OpenAI logs, API usage over time, which is time chart. So I can get it rendered like this in a chart format. So basically the usage over time of a given model based on the number of requests coming up, right? Total request count. Then API callers by IP, which IP is calling the API, right? So this 4 to 33, which is calling it for the for the given defined duration. This is the top API. So this is, we can check if it is supposed to be like that or not. So these are the use cases which I have built, and this is how we can. This combination is unique. Reason being, we have something called as detection rule, and it's a custom detection rule, right? And then we are aligning with OWASP top 10, basically to be in alliance with something which is of security concern. And third aspect is mapping with MITRE tactic and technique. These are those techniques which we have seen. So I'll just quickly give you a walkthrough of the techniques which we have seen. Mhm. So these are prompt injection, data poisoning, execution, privilege escalations, lateral movement, impersonations, execution manipulation, credential access, impact, defense evasion, right? And then similarly, we have something called as prompt injection, again, collection, supply chain compromise, data poisoning. So these mapping are important while creating the detection rule, and detection is important for us. So this is something a custom use case where, which is in alliance with security for AI. So we are specifically focusing on AI workloads and export of the logs to Sentinel, which is a SIM solution, and then writing custom detection rule, which is again in lines with OWASP top 10 and for LLMs and agent and mapped with MITRE mapping and tactics and adversarial tactics and common knowledge, right? So I hope you have liked this case study. Stay tuned.